I'm here to present a short talk on the state of NeuroBench. So, okay, what is NeuroBench? I'd like to explain benchmarking. Starting from an analogy, a benchmark can be the standard for measuring performance, and it includes the task, the metrics, and the methodology. And the analogy I'm going to draw here is like the 100-meter dash, right? So you run the 100-meter dash, and you get some kind of time for how fast you're going to do it. That's your benchmark. The act of benchmarking is running these benchmarks to profile and compare different solutions. So in our analogy, this would be like running a race. So the different solutions here are the different runners, and we are profiling and ranking each of them. That is benchmarking. And a benchmark framework puts this together into systematic benchmarking and the implementation of novel benchmarks. So in my analogy here, this would be like a federation of sports. Not only running, but there exist other benchmarks such as swimming, gymnastics, and things like this. And you can see how in these different benchmark tasks, we can have a standard and a collection of all of the different benchmarks. And I will make the point, and this is my major point, that benchmarking as a whole, under this common framework, aligns research on the tasks of interest, identifies the best practices for how to complete those tasks, and drives technological progress. So with that, I present to you NeuroBench, a benchmark framework for neuromorphic computing research. And we're very happy that representatives across many institutions, academic and industry, seem to agree that such a common benchmark framework for neuromorphic research computing is a good idea. The goals of NeuroBench have always been to be inclusive, that is community-driven, having minimal assumptions about the solutions, actionable, that is the benchmarks have common tooling, they're portable, they're standardized, you can run them, and iterative. So we provide a starting point and it gets better over time. The benchmarks, the NeuroBench is composed of these two tracks. There is the algorithm track, in which we profile algorithmic costs. So this would be, say, the number of operations that your spiking neural network uses. And then there's the system track where we actually measure deployed performance on real hardware. And so you can see the difference between these two because of the state, the maturity of neuromorphic hardware today. In terms of tasks, on the algorithm track, we have 4 tasks. Those are a keyword few-shot continual learning task, event camera object detection, neural decoding of motor cortical data, and chaotic sequence prediction. And over on the system track, we have tasks which are more aligned with the current scope of existing neuromorphic hardware, that is acoustic scene classification and this optimization task. In terms of metrics, we have the king of metrics, you could say, accuracy, both on the algorithm and system track. But in addition to that, we focus a lot on how efficient is your solution. So over on the algorithm track, we have various complexity metrics that measure the cost of how much your algorithm took. And of course, on the system track, we're able to measure runtime and efficiency directly. All of the algorithm track, which is more research-oriented, is supported by an algorithm track harness, which is open source. You can find it on GitHub. You can install it directly with the command line. It's very easy. Automatic benchmarking for neural network models includes all the data sets for the tasks I presented and more. It's natively compatible with your torch-based libraries, so this helps research, and it is actively maintained and built for extensibility. Now, I've told you what NeuroBench is. I'd like to tell you about the state of NeuroBench. So let's look at a timeline. And the purpose of this slide is really to show the building of the community and where we've been. So 2 years ago at the NICE conference, my advisor Vijay gave the initial talk on NeuroBench and presented our white paper and motivations. Last year, I was honored to give the keynote at NICE in San Diego. And where have we been since then? In July, I was with my friend Benedetto at the Telluride workshop where we gave a tutorial. In September, at the Neuromorphic Computing Summit in the Netherlands, my friends Cornel and Dawa gave a short poster on NeuroBench. In October, and I'll come back to this example, the great team run by Arindam Basu and his students Bian and Vincent at the City University of Hong Kong put on the grand challenge on neural decoding at the BioCast conference. In February of this year, our paper was accepted to Nature Communications, and I'm highlighting a few people here who were instrumental in helping develop the tools, helping develop the initial baselines, helping specify the tasks. In March, we're here today to give this talk here at NICE once again, and we have a tutorial that we're going to give on using the harness tomorrow. And very shortly, we're invited, this is in the future, to NeuroBench at ASPLOS to give a further presentation, as well as in June, the group doing an eye tracking challenge is going to use our harness as well. We got a small shout out there. So I'd like to really highlight that this is a community effort. There's a lot of people who are involved in this, in putting together these tasks, and we'd really like to see it continue as a community effort. And this is why I'm here talking to you today. I'd like to highlight some of the recent works that have come out of NeuroBench. So you can browse through these. Some of these works were presented at today's at this conference. And over on the left in red, these are works that have used the benchmark tasks, so extending on methods for the tasks. And over in blue, I'm highlighting papers which have extended on the tools and tasks that we currently have. So I like to emphasize the extensibility of what we've built, not only for the existing tasks, but also for more. I'd like to come back to this grand challenge on neural decoding, which was presented in October at the BioCast conference, because I think it really exemplifies what I said earlier, that benchmarking under a common framework aligns research, identifies best practices, and drives technological progress. So I'm going to put the results of the competition up on the screen here. And I hope you can see that the metrics are going in the direction we want. So R squared, that's our accuracy metric. These baselines, those are the ones produced for the original NeuroBench paper. And you can see the direction I wish the stock market was taking. And over here on the synaptic operations, I especially like to highlight this example of an SNN, cheaper SNNs. I will point out that if you'd like to train like what is currently the best in the world for spiking neural networks, that's definitely possible. They've open sourced their code, and with very simple scripts, you are able to validate the results on the benchmark. And if you are inclined, you can investigate and profile their work further and make further extensions to their spiking neural network. And of course, what I'm alluding to is our open source harness tooling, which supports research through NeuroBench. So my purpose of this slide is to show that this is continually maintained. We're making updates to make this a better research tool for you to use. Our latest release was in January of this year. We fully reorganized the library. We added this new interface for custom metrics. We just hope that this tool is for the community to use. And if you have, we encourage you to be familiar with it. And if you find any issues, we're happy to address those. So what's next for NeuroBench? I like to present this as questions to you, as NeuroBench has and will continue to be a community effort. So probably the question you're most familiar with, what are effective methods for better benchmark performance? What kind of algorithms can I create, training, model architectures, and so on? But with the centralization of benchmarking, we have the opportunity to treat benchmarking as a science and improve on benchmarking itself. And that includes questions like, are there better tasks? Are there tasks which are a better fit for this technology? Are other metrics more representative of better performance? And are there further software harness features which can better facilitate research? So these are essential questions which I think we really have an opportunity to ask here with the NeuroBench project. We'll be at the tutorial tomorrow. I'll be joined by my friend Benedetto once again. We'll teach you how to use the NeuroBench harness. We'll be discussing our thoughts on next directions, especially for integrating the algorithm with the system track. And of course, an invitation to open discussion on future directions. All right, my name is Jason. Thank you.